Picture this. Somewhere in Northern Virginia, an AI data center is being built that needs so much electricity, it might as well have its own zip code. And while everyone argues about which chatbot is smarter, the people writing the biggest checks are obsessing over something way less sexy. Watts. Because AI doesn't run on vibes. AI runs on electricity. And the companies winning the AI race are quietly making the same move. They're betting on nuclear. Microsoft is paying to bring back 3 Mile Island. Google is signing deals for new, small nuclear reactors. Amazon is literally building data centers next to nuclear plants. And Bill Gates, yes, Windows Bill Gates, has been pouring money into a next-gen reactor company called TerraPower. So today we're answering one simple question. Why are Bill Gates and big tech betting on nuclear? And what does that mean for your money? Stick around, because in about 16 minutes you're going to understand 1. Why AI just turned electricity into the new oil. 2. Why solar and wind can't do this job alone. 3. Why nuclear is having the craziest comeback story since vinyl records. And 4. The smart ways investors can get exposure without turning their portfolio into a science fair volcano. Also, at the end, I'll tell you the one risk that can blow up this entire thesis. And it's not the one everyone screams about in the comments. Let's go. Quick disclaimer, I'm not your financial advisor. This is education and entertainment. Please do not buy anything just because a guy on YouTube said the word uranium with confidence. Alright, first, why the AI boom is really an electricity boom. We used to think the constraint on AI was chips. Do you have enough GPUs? Now the real constraint is, can you get enough power, fast, in the right place, 24/7, without the grid face planting? Here's the scale. Globally, data centers used roughly 460 terawatt-hours of electricity in 2022. The International Energy Agency says that could rise to more than 1,000 terawatt-hours by 2026. That's an increase of hundreds of terawatt-hours in just a few years. Translation? It's huge. And it's not spread out evenly. It's clustered. Like, hello, welcome to Data Center Alley. Please enjoy your traffic and your transformer shortage. In the US, different studies put the exact numbers in different places, but the direction is painfully clear. Data centers are one of the fastest growing loads on the grid. For example, one US government report estimated US data centers used about 176 terawatt-hours in 2023, around 4% of total US electricity. An EPRI analysis has said data centers could be anywhere from roughly 4.6% to 9.1% of US electricity by 2030. That's a wild range. But even the low end is a problem if you're a utility that already needed new generation and new transmission. And AI supercharges this because the hardware is insane. A normal server rack might pull, say, single digit to a couple dozen kilowatts. High-end AI racks? We're talking dozens, and in some cases well over 100 kilowatts per rack. These things are basically space heaters that do math. So utilities are getting requests that sound fake. Hi, yes, we'd like 500 megawatts by Tuesday. Or the GigaChad version. Hi, yes, we'd like a gigawatt. A gigawatt is a large power plant. And if you can't get the power, you can't ship the product. No power, no training runs. No power, no inference. No power, no AI revenue. That's why you're seeing headlines about data centers getting stuck in interconnection queues, or companies building temporary on-site generation just to keep projects moving. Because the grid is not a vending machine. You don't push A7 and get 1 gigawatt, carbon-free, delivered by Friday. So big tech has a problem. They want energy that is massive, reliable, available 24/7, and, ideally, low carbon. Which brings us to the uncomfortable truth. I love renewables. They're getting cheaper, and they're going to be a huge part of the mix. But AI data centers have one relationship status with electricity. It's clingy. They don't want power on average. They want power right now, all the time. Because downtime for a data center isn't like your phone dying. It's like a casino turning off the lights mid-hand. Wind and solar are intermittent. That's not an insult, that's physics. You compare them with batteries, demand response, better transmission, all good. But when you need industrial-scale 24/7 power, the grid still needs firm generation. So what's firm generation? Today it's mostly natural gas, hydro, and nuclear. And nuclear has a couple of superpowers that are weirdly perfect for AI. Superpower number 1, reliability. Let's talk capacity factor, because this is the nerdiest metric that matters most. Capacity factor is basically how much power did you actually generate compared to how much you could have generated if you ran full blast all year. In the US, nuclear tends to have the highest capacity factors among major sources, meaning it runs a lot of the time. Superpower number 2, energy density. A nuclear plant puts out a mountain of power from a relatively small footprint. That matters because you can't pave 3 counties for solar panels next to every data center cluster. Superpower number 3, it's low carbon at the point of generation. And big tech has climate goals. Even if you're cynical and you think it's all PR, fine. PR still costs money. So they're buying power that looks good on a spreadsheet and on the sustainability report. And now, the plot twist. They're not just talking, they're doing deals. Let's start with the deal that made everyone's eyebrows touch their hairline. Microsoft and Constellation. Constellation is one of the biggest nuclear operators in the US. Microsoft signed a 20-year power purchase agreement tied to restarting 3 Mile Island Unit 1. Yes, that 3 Mile Island. The one everyone remembers from 1979, even though the unit being restarted is a different unit that shut down in 2019 for economic reasons. Constellation is bringing it back under a new name, Crane Clean Energy Center, and the plan is to get an 835-megawatt reactor back on the grid. And the US Department of Energy has backed the project with a $1 billion loan to help finance the restart. Translation? Microsoft isn't saying, "We hope the grid adds clean energy." Microsoft is saying, "Here's a 20-year contract, make the electrons, we'll take them." Now Google. Google signed an agreement with Kairos Power to enable up to 500 megawatts of new nuclear generation by 2035, with an initial target to bring the first reactor online by around 2030. And Kairos is not building the same giant, old-school reactor your uncle thinks of when you say nuclear. They're working on smaller, modular, advanced designs, trying to build reactors more like airplanes, standardized, repeatable, and scalable. Now Amazon. Amazon has gone full, "I would like my electricity with a side of security, please." They've pursued data center campuses next to existing nuclear plants. They've also announced deals supporting small modular reactor development, including a big investment in X-Energy and partnerships with Energy Northwest and Dominion to explore SMR projects. Amazon is basically saying, if power is the bottleneck, we don't want to rent the bottleneck. We want to own the on-ramp. And then we have Meta. Meta basically looked at its AI roadmap and said, "Okay, we're going to need the energy equivalent of a small country." Meta announced multiple nuclear agreements aimed at supporting up to 6.6 gigawatts of new and existing clean energy by 2035, including deals with Vistra, Oklo, and TerraPower. 6.6 gigawatts. That's not, "We bought some solar credits and called it a day." That's, "We are planning around nuclear capacity." So when you see all these companies, Microsoft, Google, Amazon, Meta, making nuclear moves, it's not because they suddenly fell in love with uranium pellets. It's because they're facing the same problem. AI is growing faster than the grid. Now, why is Bill Gates in the middle of this story? Bill Gates has been banging the nuclear drum for years. Not because he's bored, because he's obsessed with the math of decarbonisation. His company, TerraPower, is building a next-gen reactor called Natrium in Kemmerer, Wyoming, right next to a retiring coal plant. Which is poetic in a "we're swapping black rocks for split atoms" kind of way. Here's what makes Natrium different. It's a sodium-cooled fast reactor paired with molten salt energy storage. And that storage part is the sneaky genius. The reactor runs at about 345 megawatts, but when the grid needs extra juice, like during peak demand, it can use stored heat to boost output up to about 500 megawatts for several hours. That means it can behave like baseload and like a peaker, which is exactly what you want when you're trying to balance a grid with lots of renewables, while also feeding AI data centers that don't sleep. Now, important reality check, this stuff takes time. TerraPower's Natrium project has been moving through the NRC licensing process with a long timeline toward first fuel and commercial operation around the early 2030s. So no, this isn't nuclear will save the grid next Tuesday. This is, nuclear is being positioned as critical infrastructure for the next decade. And before the comments section turns into a live-action Twitter thread, let's do a 30-second myth check on the two biggest nuclear fears: safety and waste. First, safety. Nuclear has had high-profile accidents, and those matter. But on a per-unit of electricity basis, nuclear has one of the lowest death rates compared to fossil fuels, because fossil fuels quietly kill people every day through air pollution. Second, waste. Yes, nuclear waste is real. No, it's not green slime in a barrel rolling down Main Street. It's a small volume of solid material that is heavily regulated and mostly stored securely on site. In the US, the Department of Energy has pointed out that the total amount of spent nuclear fuel produced over decades could fit on a single football field at a depth of less than 10 yards. The real problem with waste is political, not physics. We still don't have a permanent repository in the US, so it's managed, but it's not resolved. Okay, myth check done. Back to money. When a theme like this shows up, there are usually three layers where money can be made. Layer 1, the toll roads. These are the companies that already own operating nuclear plants, or they're the utilities and independent power producers that can sign long-term contracts. Why they matter? If demand for electricity is rising, and data centers are a big part of that, reliable generation becomes more valuable. And nuclear plants are basically reliability machines. We're also seeing something new. Nuclear plants getting revived instead of retired. 3 Mile Island, Unit 1. Palisades in Michigan is being pursued for restart. This is the vibe shift, from shut it down to, wait, can we keep that thing running? And policy matters here. In the US, existing nuclear plants can qualify for federal support like production tax credits designed to keep them operating while power markets evolve. Translation: Washington is basically saying, please don't close the clean baseload plants right when we need them. Layer 2, the fuel and the supply chain. A nuclear plant is like a fancy espresso machine. The machine is expensive, but the beans matter too. Fuel for most reactors is low-enriched uranium, and one major storyline here is geopolitics. The US passed a law that bans imports of Russian low-enriched uranium, with waivers allowed only under specific conditions and only through 2027, and the ban running through 2040. Translation: the West is trying to build a friend-shored nuclear fuel supply chain. And here's why investors obsess over the fuel cycle. Supply doesn't turn on a dime. The nuclear industry's own Red Book reporting, has long pointed out that bringing new uranium mines and mills online can take a decade or more. So when utilities go from "we have plenty of inventory" to "we need long-term contracts," the whole chain can tighten fast. So this layer includes uranium miners, uranium converters, enrichment companies, and new fuel types like HALEU that advanced reactors may need. But I'm going to be real with you, this layer is volatile. Commodity cycles are spicy, and nuclear supply chains move at the speed of paperwork. Layer 3, the moonshots. These are the companies building the next-gen reactors. SMRs, fast reactors, molten salt reactors, the whole sci-fi menu. This is where people get excited because the upside feels massive, but it's also where you can lose money the fastest, because timelines slip, costs rise, and regulators do what regulators do. Case in point, NuScale's first planned US SMR project was cancelled after costs rose and customers didn't sign up for enough output. So if you want exposure here, treat it like venture capital. Small position sizes, diversified bets, and a strong stomach. Now, if you're sitting there thinking, okay, but what should I actually do? Here's a sane framework. Step 1. Decide what you're actually betting on. Is your bet A. Electricity demand growth, B. Nuclear as a policy-supported reliability asset, C. Uranium as a commodity cycle, D. Advanced reactors as a technology bet? Those are not the same bet, and they should not all be in the same bucket in your brain or your portfolio. Step 2. Match the vehicle to your risk tolerance. If you want lower drama, you look at diversified utilities or nuclear operators. If you want medium drama, you look at fuel and supply chain. If you want maximum drama, you look at early-stage reactor developers. Step 3. Watch the 3 catalysts. 1. Long-term contracts with real customers, because a reactor without a buyer is just an expensive diorama. 2. Licensing milestones. These are the "we might actually build this" receipts. 3. Fuel availability. Advanced reactors that need HALEU don't care about your optimism if the fuel doesn't exist at scale. And step 4. Respect the risks. Nuclear has real risks. Cost overruns are real. Politics is real. Public sentiment matters. And the waste problem is politically, let's call it, unresolved. Now, remember the open loop? The biggest risk to this entire nuclear renaissance thesis is not just a reactor goes over budget. It's this. AI demand might shift geographically and technologically faster than nuclear timelines. If model efficiency improves, if workloads move, if grid upgrades accelerate, if AI chips get radically more power efficient, the need for new nuclear doesn't disappear, but the pricing power and the urgency could. So you're not betting on nuclear good, you're betting on the timing. Nuclear projects and fuel supply chains catching the wave of electrification and AI before the wave moves. But here's the punchline. The world is electrifying. AI is pouring gasoline on electricity demand. And the companies with the biggest balance sheets on Earth are saying nuclear is part of the answer. So even if you personally never buy a nuclear stock in your life, nuclear is going to show up in your electricity bills, in your local grid battles, in where data centers get built, and in which companies win the AI race. And if you do invest, you want to do it with your eyes open, on the theme, on the timeline, and on the risk. If you want, I'll do a follow-up video where we break down the nuclear investment landscape, utilities, uranium, and SMR moonshots, plus the biggest red flags to avoid. Drop a comment with the word nuclear if you want that. And if you enjoyed this, hit like, subscribe, and I'll see you in the next one.